Hi and welcome back to this episode number 3 of the Regnecentralen's RC759 Piccoline. I think it's time for us to figure out what was wrong with the CPU socket. And in episode 2, I need you to watch episode 1 and 2 in order to understand where we're at, and I will put a link somewhere and down there in the description so you can see the other 2 ones. I know each of them are like an hour. Just do it on 1.5 at speed on YouTube and then it's over in the Swift. That's easier. That's what I'm doing anyway. So, loads of stuff has been happening until now, and I actually want to say 1,000 thank you to everybody who has been writing into me, commenting the video and writing directly email to me about what could be wrong with it. And I will briefly explain that people said that maybe the sockets are not good enough in the back. This is why I have this over here, so I can have a close look at it. I looked at them, they're okay. Nothing wrong with the soldering in the back, but nevertheless, I did resolder them. So they are crisp and they're working. I also have tested the connection from here until here and everything is working. That is not the issue. As we ended up figuring out, the issue is this socket CPU holder. I don't know what you call it, but nevertheless, this with the 2 CPUs came from the other computers over there. And the socket itself, it's not the same socket as that was in the other motherboard. Therefore, this bracket holder that's supposed to be holding it down is not suitable for this socket here. And I finally have got a package. I went on eBay, searched for possible solution for this, because I thought, okay, I'll just find another socket equal to this one and then I'll just solder it in and use these. But I actually was so lucky to came over the right socket and socket holder for this specific socket. So I actually have the socket holder here. I will take the camera closer and we'll have a look. We'll open this up. I haven't opened it up yet, so we can test this. Another thing I just want to say is I have obviously taken out all the refers. There were loads of them, and every single one was cracked or blown, like really blown all over the place. So everything over there has been cleaned, it's working. I have pre-tested the power supply and everything is just working. Before I take the camera closer to, I just want to point to here. Behind me, there's another one. I have been giving another one. Thank you. This is crazy. People are sending me in this computer. And this has helped me a lot because I have already cleaned the motherboard. And I have tested it. Also, the power supply is also working now. 2 refers were pulled out. And I've tested that system in order to gain the knowledge of why is this computer making errors. So with that knowledge and that computer, which is running, I have good news to share with you. And I think we're just ready to kick off this episode 3. So let's do it. Let me get rid of, have a look at this one. This is really blown up like crazy. All the other ones are cracked all over the place, but refers are just bad. But that's all sorted out. We're talking about these. These are the clips to clip onto the CPU when it's in, but not to this socket. So that was the issue. I have the 2 CPUs here. Let me just briefly take them a little bit away. I just want to explain to you the Intel CPU. They came in 3 packages. Or chip carrier. This one that we are dealing with is the ceramic leadless chip carrier, which is this socket going into these. There were also 2 other ones. There were this one, which is then called the plastic leaded chip carrier. I'm not sure you can see it's like this. And the third one, I don't have a CPU with that. It's just a regular one where you have the pins out of it. So that's the pin grid array where it's just plugging out like all of these sockets. So the CPU came in these three models, and we are dealing, this is actually an Intel 8186. So we're dealing with this. And let me take this away. And let's have a look at this package. So let me just briefly open everything up so we can see what's inside all of this. Okay, there we go. So 2, 4, 6, I have 8, and 1, 2, 3, 4, 8 of these. This socket is that socket. I don't need these, so these are spare. But I need these. And if I take, let me take this to the side. Oh, there are two here, sorry, give me a second. And as you can see, most likely it's completely something else. It's not the same thing. And this one is the one that goes down here. So let me try and get this down there with the CPU, obviously. And as you can see on these, there are no heat absorbing things like this. So I need to have some cooling on it also. But somehow I need to figure out how it goes in. I think it's just like plugging it in. I will come back to you once I have put the CPUs in and put these brackets on them. I don't know what they're called, sadly. If somebody actually knows what this is called compared to what this thing is called, so then write a comment to me. Let me put this in, and then we can continue testing the computer. They're in, and this bracket really pushes down on the CPU, so there's no doubt about this is the right one. But if I turn this on, this would be too hot, so I need a tiny heat shrink on this one. So let me just find one. So I have a few of these. I'm not sure this is good enough, but let's just try and put them on. There we go. This looks pretty, right? So I think we are kind of like ready for me to hook up everything back again and see if we are lucky this time. And I'll just very briefly clean up my table so we can see the computer running. And as I had the other computer, the new one that I've tested, I have actually also figured out that, and let me maybe arrange the camera a little bit over there. I have a flat screen monitor, and it turns out that I can use this instead of the original monitor, because that will flicker due to the frequency. So I will set this up with this monitor, and then we'll turn it on, and let's see what happens. Okay, let's turn it on and see if I hooked up everything. There's still just the things that need to be in. The battery's hooked up. I actually also know what the arrow in episode 2 when we ended up the 0019, what that means, but I'll come back to that. Let me, the keyboard is clicking, which always is a good thing. which usually means that it's working. So let me see if the monitor is picking up the computer. It is. Amazing. So over here we see 4 dots now, and we see error 00019. 19 means that the computer has lost all its BIOS settings, so you need to go into the BIOS setting of the computer. And I have looked at the manual, and it just means press on space, and then you're in. And this is the BIOS. It's a weird BIOS, but if you change the parameters, I think it was, just in order to confirm default values and save it to the computer, you'll then be able to continue. So let me try 3 up here, and I'll just say yes to everything. Hold on errors, loop in test, boot after test, suppress status check, suppress data check. It's always no. And I don't know what that means. And then enter. And I think if I then say proceed test with 0, incorrect checksum. Okay. Weird. Let me try again. Control Alt Delete maybe? I don't know. This one? There we go. So there's Control Alt Delete, which means boot. So this goes into the boot menu. There's an L, configuration of system parameters, or W, configuration of clock date parameters. Let's just do L and see what that leads us. And then it asks for the comp port down here, the baud rate, and I can just accept all these settings on Y as in yes. And then what? Escape? I don't know. Enter? No. W. I think it's saying non-existing medium. Maybe it's because I haven't hooked up floppy disk drive. But let me just briefly turn it off and turn it on. Keyboard is clicking. Monitor's going up. 1 star, 2, 3, 4, 4. Now it's counting up. Now everything is working. I think what this is because it cannot see the card that needs to be here, which is for the floppy disk drives. So it now actually needs to know how am I supposed to be booting this computer. You could have had operating system on EEPROMs here. The Danish develop a programming system called Comal could also have been on EEPROMs, and it could then boot into that. I think this is what it's doing. I haven't read up too much of this. I just needed to see if it's working. But nevertheless, this one is working. Let's try and hook up a floppy disk drive to this unit and see if it want to boot on a floppy disk. I have a bootable CPM floppy disk for this computer also. Let me rig all this up and let's have a look at that. So this is the floppy disk controller card, I will assume we're going to call this. It's called DPA701, so disk printer adapter, that's the name for it. So let me just put this here. And it's in. Let's turn it on again and see if this helps it further on. No. Now it's not working anymore. What's wrong? Let's try again. There was the click. There's going to test. Something's wrong. Oh, now it's turned 1 dot. Now it's very slow, but it's up now. Okay, there we go. Okay, so now it says load medium on drive A. So now it knows that this card is in, that it can continue in the next step of trying to find a boot media, which should be on the floppy disk drive. So, okay, we're on the right track. Nice. Now I want to hook up the floppy disk drive. And with that, I think we're finally ready. Let's turn it on. So floppy disk drive down here, CPU up here. It's turning on over there. I hope everybody can see. I think so, yes. I have a floppy bootable disk drive. It's asking for that, and it's saying, and this specific unit is the unit that where you can have 4 CPUs connecting to one. So it now actually, because A is lighting up, so it knows that A is requesting access, and this is now A, because in the back, this connector goes to A in the back of the floppy disk drive. So let me try to put this in. This is the first time ever. It's saying something. This should boot into Concurrent CPM. It is. Piccoline X iOS version 2.3 of March 1985. 256 kilobyte, that's this memory that's on board. The 2 disk station, that must be these 2 drives it sees. I don't know what the data buffs is or the catalog buffer, and it says once all the system has taken their part of the memory, we have 165K of memory back. Concurrent CPM 86, version 3.1, copyright from Digital Research. This is a console with 1 terminal because there's only 1 connected to it. So, nice, absolutely amazing. First off, let's do D on the drive, right? So D, too much, there we go. Crazy. Look at the soft scrolling. Let me do D again. I hope you pick it up on the screen. It's scrolling like super, super soft. I just want to feel how hot it is. It's getting hot. It is. I think somehow I maybe need to find a fan for this, but I don't have one yet. So that will be a future project for this one. The problem with this is the power supply, as I told you on episode 2, doesn't fit into this board. So in order for me to get the power supply in here, I need to modify the power supply so the holes that are going into these needs to be wider, and this one doesn't exist on there, so either I need to remove this, which I won't, or I have to drill a hole in the back. Let me turn it off. In the back of the power supply. So, sorry, it's, yeah. So I need to drill a hole where my finger is now in the power supply in order for me to fit it in here, and then I can put the casing up and everything is done with this one. We have some extra memory. Let me try and just put in the extra memory that was on the other computer and see how much memory we are then gaining. So hold on a second. Okay, found the memory. And let me just turn off the power. I'm not sure. I think this is 256. I'm not sure. And it goes in like this. And you're not supposed to be doing anything besides just plumping it in, and then the computer should figure it out itself. So let's turn it on again. See if the computer... The clicking noise is back. It's amazing. Now it's saying error 0002. I think this is just because we are putting in new stuff. Let's see. Let me try and press spacebar. Yeah, okay. So then it goes into the BIOS settings. And what is it saying? It's saying it's doing memory test, RAM memory error. So is it not working? Let's just say continue, maybe? I don't know. 0? RAM refresh test. There we go. Okay. It's booting again on the floppy disk drive. The thing when you plop this in, it needs to load that specification itself into the non-volatile memory somewhere for the BIOS set. Okay, we are on 768, so this is half a megabyte of memory. So let's do D again, just to verify it's working. I'm still pressing on the keyboard, obviously. I know you can't see the keyboard. And I have not that much knowledge about CPM, so I'm not gonna talk too much about CPM, but when I was young, I was at school and we could have a class where we were being put in front of this computer, and I was programming in Comal 80, Comal 80, which is a Danish developed computer language, programming language. It's almost the same as Pascal. It's somewhere in between Pascal and BASIC. It's Danish developed. And I can actually see there's Comal 80 over there. So if I write here, C star point star, just to verify on the screen. Yes, that is. So if I write Comal 80, and let me just tell you, I can't remember anything about it. But it's like BASIC. But it's also like Pascal. But it's with line numbers. So I think if you do like 10, is it clear? To clear a screen. 20 to print. No, misspelling. Hi. I'm RC759 and run. Yeah. Or no, it didn't do anything. List. Why am I not seeing? Okay. I know there's no go to as a line number. You need to have a label. So if I make 15 start. Colon. Let's do list. Yeah. And then 30 go to start. I think that's how it goes. I am so rusty. Run. Yeah, there we go. Hi, I'm RC759. Look at the super slow and smooth scrolling. This is amazing. I distinctly remember this. How do I get out of this? Control C, or maybe just escape. The red escape. Yeah, okay, escape works. List. Nice. Okay, let me arrange the camera and let's have a talk. So I thought I should just very briefly talk about the issue we had with the sockets. So this is the board that we stole the CPU and the graphics processor from. And if you look at this socket, and let me see if you can see it, I hope so, yeah. Which had this one on it. And they just clip on the sides. And if I can do this whilst holding it, hold on a second. It goes in like this. That's that one for the CPU. And we were talking about this socket, which is not the same as you can see. And it was sitting like this, where this tab that was holding the CPU when you pressed it in on this side, I'm not sure you can see it. And this was the bracket for it. And the bracket with the hole needs to go up there. Well, there's one on each side, but they have to go like this. So therefore, this went underneath. I hope we can see it. And when you pushed it down, it locked in the CPU. So that was the deal. I just need to know what this name is, because I'm trying to figure out whether or not you actually can find a fan that runs with it so that I can cool the other CPU. But there we go. That's the difference between these two. I have also, let me take this to the side over here. I have also meanwhile gone a trip to the glass blaster, and I just removed all the rust and all the paint. And the paint is, as you can see, all gone. It is smooth, all rust is gone. I sadly, if we do like this, I obviously missed all the naming in the back. The logo that was over here, and the Piccoline name was over there. I also did the same on the top cover, which is also nice. Obviously, you can see it still needs to be painted, but nevertheless, that's gonna be another project. I don't think I'm gonna make a YouTube out of refurnish this back into the original painting. I don't think we need to see that. So that's the status with all of this. I just briefly wanted to talk about, look how dirty my fingers are, the Intel 8186 CPU. This is not the same type that went into our boards. This is actually an N8186. These were running at 6 megahertz. This one is actually running at 8. The reason why Intel made this CPU, the 186, is a little bit strange. But the reason why I find it a little bit strange is that they also, at the same time, the same year, they made the 8286. But this was more intended to make to use in embedded system, like a microprocessor. And the thing they did compared this one to the 8086 is that all the external system for the 8086, such as the clock generator, the interrupt controller, a timer, the wait state generator, DMA channel handler, and all this, what are they called? Chip select lines, and so on and so forth. All these chips that were on the 8086 board, they incorporate all that into this. And that actually made the CPU faster, obviously. One of the things that was really fast they figured out once this was released was such a simple thing as multiplying and division. They were much faster than the 8086, even though this one is completely compatible with the 8086. The things that we are having here in the board, that's the 8186, but it's the CMOS version, so it's the 80C186 version, which then also could handle DRAM refresh over here. I was trying to locate what other computers besides this Piccoline and the other computer from Regnecentralen called Partner, Piccolo, that was made with this CPU. And I came over that actually Tandy 2000, the desktop computer from Tandy, that was also with the same CPU. HP also made a few Palm Palette or Pan laptops, small devices like the HP 100 and HP 200, I think it's HP 1000. They also had that CPU. IBM even made one very weird computer with the 8186. That was called the IBM PC Radio. It was kind of like a notebook thing, and that was a huge flop, like the rest of everything that was produced with the 186, because the 286 came out at the same time, and obviously it was a much better and faster CPU. So that's kind of like a little bit of the history about the Intel CPU. I think it's time that we somehow wrap all of this up and have a talk about what has happened, where we're going from here, what is the deal with the Regnecentralen's computer, with the Piccoline, and let me just kind of like arrange the camera so we can have a look at that. Yeah, I think it's time that we wrap this episode 3 up. I just want to make a short note that the Intel 8186 came out in 1982. Let me just show you a diagram of the other CPUs that actually were before and after that one. So it more or less all started with the 8008, well, the 4004, but the 8008 and the 8080 were together with the 8085, the 8-bit series from Intel. And then came the PC era, where obviously IBM were the major game player in that thing. They had the 8088, but it was actually the 8086, the real 100% 16-bit CPU version that came out in 1978. And then it just went on and on and on with the 186, the 286, 386, and obviously the 486. And here you can actually see how the transistor, the amount of transistors that were on a die, that they grew like rapidly. So the 86 had, the 8086 had 29,000, and the one that we're talking about today, the 8186, went on up to 55,000. That's mainly due to that they incorporated all the external logic into this chip. And at the same time, also in 82, came the 8286. It's a lot of numbers right now, right? That then had like 130 something thousand transistors. And then it just went even crazier and crazier. So I just want to say thank you for staying for this episode about this Danish computer. We have just briefly touched the surface of the computer itself and the company Regnecentralen and the computers that kind of like came before this one. I somehow feel that I want to talk way more about the Danish computer, not only the Piccoline, but the other computers that were prior to this. But I think we have had 3 episodes, and that should be more or less enough for now. I think eventually I will bring some of the other computers forward, and we'll have a more in-depth talk about the Danish computer company Regnecentralen. It had ups and it had downs, and it produced weird computers, and more or less, I should be kind, but more or less all of them were like not really into the game, because just like this machine, it wasn't a PC compatible computer, even though at that time the IBM PC has been out for at least 3 years. So why did Regnecentralen here in Denmark produce a computer that wasn't compatible with that and stick to the CPM operating system? There's so much more knowledge, there's so much more history about this company that I want to bring forward, but that's gonna be another time. We are running out of time, and this is going on for like forever, it seems. But I'm getting boobscabs now. I really enjoyed working with this, because this was the PC. I'm doing this in when I went to middle school, that I was allowed to work on. And it was more or less the first computer that I actually made programs in the Danish developed language Comal 80. And it really brought back so many memories. Since I have posted episode 1 and 2 and a little bit on Facebook about the computer, I have had a few comments from other people who either also have been working on this computer or have family members that were teachers doing classes about the computer, and they more or less, I'm saying it's wrong word, hated the computer. Obviously because there was a PC, and Regnecentralen forced this one into the schools. But I do not recognize that. I really enjoyed this computer. I loved it. It was beautiful. It was pretty. The keyboard was amazing. Remember, at this time, I had the Amstrad CPC 464. So this was a game changer for me. Double floppy disk drives and all that fancy stuff. So I really can I only remember that I had fun and loved the computer, and it was fast and all the nice things. So, but maybe it's just because I was not responsible for any of these. I didn't understand the inner of it. I just saw the programming. I saw the screen, the keyboard, and the box where I put some floppy disk in. Maybe that's it. But nevertheless, I find this as being a beautiful computer. There's even more history when this came out to the schools, because Regnecentralen also produced external peripherals to this computer, not only the floppy disk drive, but they also produced cards so that in the schools you could hook up I/O devices. You could turn on lamps or turn on a motor and stuff, and you can just program it within the computer. It all came out. That project was called Atom. And again, if you want to read more about this computer, really want to learn about all the good things that this had with it, you need to go on the Danish Computer History's homepage. I'll make a link in the description. I think I've done that before also. And read up about this. Look at all the external peripherals that they had. They even had a turtle, a effing turtle with a pencil in it. So when you draw in, I think the programming language is called Logo. So you said 5 ticks up, go to left, and then the turtle will do all that. So amazing stuff on the side for this computer. Another comment I just want to make is not only is the CPM language, this was concurrent CPM, but the CPM language was also widely spread and widely known. So it was a good operating system, obviously. But we were also talking about the programming language Comal 80. And Comal, lots of people in the vintage community most likely know about this programming language, and you could have had it to the, I think the VIC-20, but at least the Commodore 64, you had it on that one. You could have had it on Atari computers, the Amstrad computers. The Comal language was really rich, widely spread, so that was a huge language. You could have had loads and loads and loads of other application for these computers. On the homepage for the Computer Society, there are images where you can download all the images for calculation, spreadsheet, the text, finance systems, education system, loads and loads and loads. There are hundreds of software solutions for this actual computer. I think this is enough me talking. I think we should say, well, I should say thank you for staying this long. I hope you enjoyed this weird struggle with this computer when all in all it just came into the sockets that were crazy. Thank you once again. Thank you everybody who has responded or writing to me about what I should do or how they have been working with this computer. This was really a joyful adventure for me, and I hope to see you very soon again. And you know, this one or that one, and please do subscribe, all the YouTube stuff. And from here, I want to say goodbye.